Okay, subtopic 3.2 Ohm's law and resistivity. Learning outcome is state Ohm's law. Ohm's law states that the potential difference across a metallic conductor is proportional to the current flowing through it if its temperature is constant. So we can rewrite equation V is directly proportional with I. So equation from this we can write as V equal to IR, where V is potential difference of voltage, I is current flow, and R is resistance of the conductor. So same goes with your experiment result. You get that when you're changing the value of R in resistance box or rheostat, that the current and the voltage will be changing, but they are in directly proportional lah. Maksudnya bila V you increase, I akan increase. Okay, figure below show the linear relationship between V and I for metal or ohmic conductor. So dalam buku you ni, you tukar perkataan dia adalah ohmic conductor. Okay, materials that obey Ohm's law are materials that have constant resistance over wide range of potential difference. We call it as ohmic conductor, iaitu pure metal lah, lagi banyak free of electron dia. And then graph yang kita akan represent based on Ohm's law adalah straight line graph lah. Okay, so material does not obey Ohm's law means that dia punya graph bukan straight line graph, iaitu gradient dia you tak boleh baca is directly with R lah. Okay, so known as non-ohmic conductor, ataupun dia boleh cakap sebagai carbon ataupun semiconductor lah. Kebanyakannya adalah bukan pure metal. Okay, next is define resistivity. Okay, before you know about resistivity, you kena kenal dulu apa dia punya komponen dan apa itu dia punya rintangan. Okay, so resistance ni adalah rintangan. Okay, resistance is defined as the ratio of the potential difference across an electrical component to the current passing through it. Maksudnya kerintangan lah. Okay, lagi tinggi kerintangan means lagi susah. Lagi tinggi rintangan maksudnya susah lah current nak flow kan. Okay, so based on Ohm's law, so rearrange equation R equal to V over I. Okay, so itulah R lah. Okay, secara matematik kita boleh cakap lah, it's measure of the component's opposition to the flow of the electric charge. Maksudnya component opposition, yang component adalah resistor lah. Okay, resistor, penentangan resistor terhadap laluan current. Okay, so resistance juga you boleh samakan juga dengan rho L over A. Ni equation ni tolong salin sebab tak ada dalam you punya buku. Okay, so maksudnya dekat sini nak cakap resistance is depends on, okay, type of material is rho lah, length, area is cross sectional area, and temperature of the conductor. So kita boleh cakap dia depends pada V and I lah, sebab ni adalah paling basic equation yang dia ada untuk resistance. And then the scalar quantity and unit is ohm ataupun volt per ampere lah. Okay, so next adalah resistivity, means that kerintangan. Tadi tu rintangan, ni kerintangan dia. Okay, resistivity is defined as the resistance of the unit cross-sectional area per unit length of the material. So based on equation resistance tadi, okay, kita akan tukar resistivity is equal to RA over L. This one is we only use for calculation only. Okay, so where R equal to resistance, A equal to cross-sectional area, and length of the conductor is L. Okay, it's a measure of the material ability to oppose the flow of an electric current. Ability, material ability, kebolehan material. So kalau you different material, you'll be affected by different resistivity. So resistivity depends on type of material and temperature only. Dua sahaja yang akan affect resistivity ni, rho ni. Even though the equation dia ada relate dengan R, A dan L. Kalau R berubah, A berubah, L berubah, so no change with resistivity because resistivity only depends on the type of material and temperature. Okay, boleh Okay, macam biasalah. And then good conductor, of course lah, dia punya resistivity adalah lower. Good insulator adalah penebat, dia mesti high resistivity. VT. Okay, skala kuantiti dan unit adalah ohmmeter. Ni adalah resistivity ohmmeter. This is table show that resistivity for various material at 20 degree Celsius. Kenapa 20 degree Celsius? Ni adalah reference temperature pada overseas punya book lah. Okay, so kita pun pakai. Alright, so different material will produce different resistivity. Resistivity. So maksudnya resistivity ni hanya bergantung kepada material dan temperature sahaja. Okay. Okay, so let's try this. We have a light bulb drawn a 450 milliampere of current from 2 volt battery, and then if the battery becomes weak and the voltage drop to 1.5 volt, what is the change in the current if the resistance remain constant? Okay, based on the information given, V is 2 volt, I initial is 450 milliampere, we can determine the value of resistance. Okay, resistance is equal to V over I initial. So we get resistance is 4.44 ohm. Okay, so then after we get the resistance, because they said the resistance remain constant, so we can determine the value of I when the voltage is dropped to 1.5 volt. Okay, jadi kita akan kira I final lah. When the voltage final is 1.5 volt divided by the same value of resistance, we get 0.34 ampere. So the question asks is what is the change in the current? Change in the current means delta I is equal to I final minus I initial. So saya buat modulus lah. Okay, so we get the change of the current is 0.11 ampere. Alright, so next is let's try this. What happened to the resistivity of a given wire when its length is increased by 1/2 while its cross-sectional area is reduced by 1/3? So remember that when we talk about resistivity, it's only depend on two types. First is material and the second one is temperature. So the answer is D. No changing or remain the same. Because resistivity only depends on type of material and temperature.